Let's start by thinking about how you approached it, okay? The overwhelming number of you, and at this point in the paper, I don't think it was that bad an idea. The overwhelming number of you drew this, right? Well, yours didn't look as good at this, but you know, you get the idea. You tried to draw this, and then you said, well, look, you know, from the graph, you know. Now, that's not bad. That's not bad, but you had to do more than that, okay? Because the thing is, this entire argument sort of falls on your graph being exactly accurate, right? Now, who are you to say the graph doesn't look like this? Okay. Now, for 2 marks, a graph was not enough, okay? You need to make some comment about why you see the critical thing is whether this gradient, right, is always above the other gradient, okay? Now, some of you said this. Some of you said this. Look, you worked out this. It's just e to the x. You said, look, it's always positive. It's always positive. And then you worked out this, x plus 1. And you said, look, it's always positive. So this is increasing, and this is increasing. So that means this one's always on top of this one. Really? The problem with that is because you could have taken the exact same logic and argued it exactly the other way around, right? You could have said, look, this is increasing and this is increasing, so I just arbitrarily picked this one, and I want that one to be on top, okay? So that argument didn't hold water, even though a lot of you used it, okay? So either you graph this, and then you had to make some statement about the derivatives, or let me show you a completely different proof, which I think is kind of elegant, okay? And I kind of like it, okay? Have a look at this. This is what you are required to prove, right? Now, part of the reason why a lot of you stumbled over this is because you took that and you said, okay, I'm just going to run with it, okay? Inequalities. Inequalities. One of the key things, one of the key strategies about how to approach inequalities is that proving A is greater than B for any A and B, sometimes it's easy, sometimes it is hard, sometimes it's obscure. A much, much easier thing is always to prove that the difference between them is positive, okay? Because we know tons of things about positive numbers, right? Like if I can get a square over here, or if I can use calculus to do something to this, right? This kind of quality is mathematically much easier to find, right? It's a lot easier to prove conclusively. So therefore, in this case, the game that I would have played is said, well, let's just consider this guy. Like consider this. Okay, this is the approach I'm going to take. If I consider this, I want to prove that this thing is positive in the given domain. Okay, now this is quite straightforward. It's quite straightforward. All I want to do is prove that it's positive. Okay, so I say, well, all right. If I want to prove that it's positive, let's start by proving that it's increasing. Right? It's never going to go down. It's always going to go up. Okay. By the way, this graph, it looks something like this, roughly. Okay. Anyway, you can work that out. I did the derivative, which is very easy. Derivative of this is just e to the x minus 1, right? So I can say, wait, hold on, look at this guy, right? For x is greater than 0, right? E to the x is greater than 1, right? That's just a fair fact. So I can say e to the x minus 1 is greater than 0. So therefore, my derivative here, I should call this f. My derivative is always positive in this domain. Okay, so it's increasing. Now that I've established that it's increasing, all I need to show is that it was never below 0, right? If it was always a 0 and going up, because it's increasing, it'll never go below. So then I've proved this, which means I've proved this. Okay. So then you say, well, have a look at this graph, right? You can find the stationary point, and you can say, you know, the minimum, the absolute minimum of f of x in this domain, right, is y equals, or f of x equals 0. And it happens at 0. Okay? So therefore, your rock bottom is 0, right? Don't forget, I'm not inclusive of the boundary, so this point is not a problem for me. But I've also shown that it's increasing, right? It's not even like greater than, it's never going to go flat either. It is strictly increasing, right? Must increase. So that's it, that's enough. Therefore, f of x is greater than 0 for this domain. So that means this is greater than 0, which means that this is greater than that, and you're done. Okay? So, always remember you can go back to things like this. They're almost always easier to prove. And by the way, this is very different from doing like left-hand side and right-hand side and manipulating them together. Okay? I've considered something completely separately and then proved things about it which take me back to what I'm required to prove.